Today we are looking at acids and bases part 2. So from part 1, some important things to remember. Acids produce the H plus ion when put in a solution, and bases produce the hydroxide ion or OH minus ion when put in a solution. The pH scale ranges from 0 to 14. Anything with a pH of less than 7 is an acid, and anything with a pH of greater than 7 is a base. Now, some of the new information we have today. Every solution contains some hydrogen ions and some hydroxide ions. So some of this characteristic of acids and some of this characteristic of bases. pH, when we've been talking about pH, what that's actually referring to is the hydrogen ion concentration. So how concentrated the solution is with hydrogen ions. The more hydrogen ions, the lower the pH is going to be, and the lower the pH is, the more likely it is to be an acid. pOH is something we're introducing new today. Similar to pH, pH refers to H plus concentration. pOH is going to refer to hydroxide ion concentration. Now, how you are going to calculate these. This is the equation we are looking at right here. Remember how our pH scale goes up to 14? Well, pH plus pOH, meaning the concentration of hydrogen ions plus the concentration of hydroxide ions, is always going to equal 14. For example, if we were looking at Coca-Cola, and we found that Coca-Cola had a pH of 3.5 equals 14. And I wanted you to solve for the pOH. All you would do is plug in your numbers here. So I said Coca-Cola has a pH of 3.5. What is its pOH? Well, you know you can put 3.5 here to represent pH, and you know the answer has to be 14. So then all you have to do is solve for this equation, which all you would need to do is subtract 3.5 from 14. 14 minus 3.5. The pOH of Coca-Cola in this case is going to be 10.5. Now, when we are trying to determine whether something is an acid or a base, we still want to pay attention to the pH. So remember, the pH has to be less than 7 to be an acid and more than 7 to be a base. So in this situation, our pOH is 10.5, our pH is 3.5, therefore we have an acid because we are looking at the pH to determine whether it is an acid or whether it is a base. Another quick example. If I said pOH of an item equals 6.5, I want to know two things. I want to know what is its pH and is it an acid or a base. Well, I go over here and I look at my equation and I know the pOH. So I would say pH plus 6.5 because I plugged in 6.5 for the pOH equals 14. Now I need to solve for the pH. How am I going to do that? I just subtract 6.5 from both sides, so 14 minus 6.5 gives me a pH of 7.5. Now the second part of that question is this an acid or is this a base? Well, remember, when determining that, we want to look at the pH. So we look here, we look at our pH, it's 7.5. We go back up here. We see that anything greater than 7 is a base, so we know that this equals a base. So that is a basic intro into pOH and pH. Really need to focus on this equation. As long as you plug in things correctly and remember what pHs are acids and what pHs are bases, you'll do just fine with that. Now, continuing just for a few more things. The pH relationship, when referring to pH, the lower the pH, so the lower the pH down here by 0 and 1, the higher the H plus concentration. All that means is the more acidic we get, the more H plus we are going to have. So like a battery acid with a pH of 1 is going to have a higher H plus concentration than wine here with a pH of 4. So the lower you get on the pH scale, the higher the H plus concentration. So you just need to know H plus concentration increases as it becomes more acidic. So therefore, the higher the pH, so as we get up here, the lower the H plus concentration. And like I said in the last slide, pH still determines whether it's an acid or a base. So even when we're using that equation, pH plus pOH equals 14, always look to the pH to determine whether or not it is an acid or a base. Now, last part of our acids and bases part 2 is how pH and pOH are actually measured. Scientifically speaking, they're actually measured in scientific notation. So pH is measured in H plus concentration, as mentioned back in the first slide, and pOH is measured in hydroxide concentration, or OH minus concentration. So looking at this, if we look at 12 right here, if we look at the 12 right here, for some reason my pen today not working, so I'm just going to point to it. So if we look to these numbers in pH and scientific notation, the exponent right here, that represents the pH of that solution. So if it is the H plus, so if it's pH and we're solving for the H plus ion, you'll just be given this, and you just need to know, and I would label this in your notes, if it's H plus equals, then this exponent equals the pH of that solution. So the pH of this solution would be 12. The pH of this solution would be 1. The pH of this solution would be 5. So with this, it's always going to be a negative number. Just convert it to a positive number, and that is going to be your pH. And that is for when we are solving with the hydrogen ion. So H plus equals, and then you just know this is your pH. So this is 12, 1, and 5. Now the trick is the pOH does the exact same thing. So you have to know whether you're looking at the hydrogen ion or the hydroxide ion. With the hydroxide ion, if we are solving for the hydroxide ion, that means we are solving for the pOH. So in this situation, our pOH is going to be 12. Our pOH is going to be 1. And our pOH, I don't know why I put a 15 there. That is absurd. Probably just seeing if anyone would notice. Not really. We'll switch that to 11. Our pOH here is going to be 11. So for example, if I gave you this problem right here, if I gave you H plus equals 1 times 10 to the negative 12, and I said, what is the pOH of that problem? Well, you would know that the pH is 12 plus pOH equals 14. So then you would solve and you would find out that the pOH equals 2. Now, what if I wanted to ask if this was an acid or a base? Well, remember, to determine if it's an acid or a base, we always look at the pH. It is 12, it is greater than 7, therefore this would be a base. Now if we look over here, pOH in scientific notation, here we're solving for pOH, right? So pOH in this situation equals 12. So we go down here, we have pH plus our pOH is 12 equals 14. What is our pH, and is it an acid or a base? Well, our pH is going to be 2 because 14 minus 12 is 2. And therefore we are going to have an acid because we always look at pH to determine whether it is an acid or a base. So with this, all you need to really do is determine if you're looking at the hydrogen ion, which means you're solving for pH right here. You don't have to really solve, you just have to look at the number. Or if you're looking at the hydroxide ion, which means you're solving for pOH right here. And then you just have to plug in to our wonderful equation here, pH plus pOH equals 14. So we'll practice with this a little bit, but make sure you took down these notes and labeled that H plus we're solving for pH, and OH minus we are solving for pOH, and then you know how to plug those in to our equation here. Farewell.